Harrison Chase's article, Your Harness, Your Memory, makes a sharp point. The real moat in agent products is not just the model. It is the harness that decides what context gets loaded, what tools are available, what memory survives, and what work becomes reusable. We are going to walk that argument using the actual deep agents docs, the public GitHub repo, the CLI surface, and the ACP integration. Quick framing before we dive in. This style works across coding agents, it fits the current setup, and the execution can stay fully local, with conductros.com just serving as a brief operator surface reference. Start with the official positioning. Deep Agents calls itself a batteries-included agent harness. The overview page says you get planning, file system-based context management, subagents, and long-term memory without stitching the whole loop together yourself. The repo says the same thing in plainer language. Planning, file system access, shell execution, subagents, and smart defaults all come built in. That matters because Harrison's article is really an argument about where product quality comes from. Not from one magic prompt, and not from a raw model benchmark alone, but from the runtime around the model. The article's strongest claim is that memory is not a detachable plugin in practice. It lives inside the harness. The memory docs make that concrete. Deep Agents treats long-term memory as file system-backed memory. The agent reads and writes memory as files, and the harness controls where those files live, what gets loaded into the system prompt, and what gets pulled in on demand. That is exactly the lock-in point Harrison is warning about. If someone else owns that layer, they do not just host your model calls. They shape what your agent remembers, what survives across sessions, and how portable that memory really is. Skills are the other half of the argument. The skills docs describe reusable capabilities stored as skill folders with a skill.md file, optional scripts, optional references, and optional assets. At startup, the system reads the front matter, then only loads the full skill when the task actually matches. That progressive disclosure pattern is important. It keeps context lean while still letting the agent pull in richer procedures when needed. Pair that with agents.md style memory, and you get a clean split. Always on memory for stable context, skills for task-specific workflows. That is a real harness decision, not an abstract model feature. The CLI surface makes this argument easier to feel. The Deep Agent CLI is not presented as a thin chatbot wrapper. It is an open-source terminal coding agent with persistent memory, custom skills, shell execution, MCP tools, planning, and approval controls. In other words, the product is the operating loop. The model is important, obviously, but the useful behavior comes from how the harness stages files, remembers patterns, calls tools, and keeps long sessions from collapsing under their own context. That is why the article keeps insisting that if you do not own the harness, you do not really own the memory. The ACP integration is good proof that this is not just a theory page. In the public repo, Deep Agents ships an ACP connector for editor workflows. You can see the Z-thread creation surface, and you can see the real motion demo in the ACP assets. That matters because it shows the harness crossing surfaces cleanly. Terminal, docs, repo, and editor integration all line up around the same idea. The harness is the thing that carries context, tools, memory, and workflow behavior forward. The model can swap. The interface can change. The harness logic is what makes the agent stay coherent. Now look at the comparison page. Deep Agents is framed against Claude Agent SDK and Codex as the more flexible option when you want custom general-purpose agents instead of a single provider-shaped path. The page leans hard on model agnosticism, composable human-in-the-loop controls, and deployment flexibility. Harrison's article explains why that matters. Once memory and state move behind a proprietary boundary, switching gets harder. Your prompts may still port. Your real operating history usually does not. So this is not just ideology about open source. It is a practical argument for keeping your memory layer and your harness design under your control. The source article lands on open memory and open harnesses, and the repo gives that thesis concrete support. The README calls Deep Agents 100% open source, provider agnostic, and built on LangGraph. The docs show memory files, skills, subagents, and deployment patterns as first-class parts of the system, not sidecars. The repo also gives you real proof assets, the CLI image, ACP demo media, example agents, and agents.md patterns. Put together, that is the real takeaway. Better models still help, but the durable product advantage comes from the structure around the model, especially the parts that preserve memory and reusable procedures. So the clean conclusion is this. Harrison Chase is arguing that harness design is where agent products either become portable and compounding or locked in and brittle. Deep Agents is useful here because the public docs and repo let you inspect that claim in the open. You can see memory, skills, the CLI, and editor integration instead of taking the story on faith. Final quick note. This workflow still fits the current setup, still works across coding agents, and can remain fully local when you want it. Source links, docs, repo, and conductros.com are all on screen.